Hello guys, so welcome to my channel. So today I will discuss about something machine learning stuff with Kivy, and which is work on desktop, also will work on Android. Okay, so and this application, what is it is going to do, it will take something, some detect some face, okay, human face. So I just imported all Kivy's stuff, okay, here, and use NumPy. See, we don't need OpenCV here, okay. NumPy, Dlib and Kivy is enough for to do the like face detection stuff. And NumPy version should be like 1.226, less than 1.26, otherwise Dlib will not work, okay. So here I have done something modification of the Kivy camera. So for that I just use core camera, like from the Kivy core camera. I'm not using Kivy UIX camera, okay, that camera widget Kivy provide. I'm using the core. So I'm creating the camera widget from this core camera. So what I'm doing here, I'm just using relative layout and doing something like play, index, okay, resolution, these properties, and doing some initialization, okay. And by default it is the index is 0. Index is 0 means the back camera, and index is 1 means first camera, okay. If you have more than one camera, then it will goes, you can select by changing the index, but by default it is like 0, okay. And something like it is, I'm just attached event here like on update, okay. So and I have added one something canvas instruction like canvas before, okay, and paste a rectangle here, and the position should be 0 because of this relative layout, okay. When you are using relative layout, it will calculate the relative to this one, okay. So and also we have to do some bind like update rect, means that when it will resize change the positions, and it will automatically call these functions when the relative layout change position and size. So in the update you should change set again, it is like rectangle position is 0 means here, and size equal to self size means the relative layout means this widget size, okay. So now that is done, and when actually you start camera, means that on play, okay, you just set play equal to true, means it is a Kivy property like boolean property, and on true automatically when you just change the play value equal to false to true, then it will call automatically on play, okay. This is the Kivy property, advantage of the Kivy property, like on play, okay. Then it will just, this is the object and this is the value, then which value is changed, okay. So then it will start the Kivy camera, the core camera, okay, which will take texture from the internal hardware, okay. This is the core. And also it will just else means it will just stop the camera, and it will clear the texture and ask bit for safety, means that it should update the texture, okay. And this is the same thing while you are just changing the index, okay. So this is how the camera widget is working, which you can also see in Kivy website, okay. That is something like Kivy UIX, something like it was inherited from like image, okay. I'm not using that. So this is the widget stuff already done, and when we get the texture, means that from this core camera, means that what when it camera will start, it will take capture image from the camera sensor, okay. And what it will do, it will just do something like to update the surface. So for that, when the texture is new textures come from the hardware, and it will call the update texture again and again like 30 fps, okay, means the 30 frame per second, means it is called 30 times per 1 second, okay. So I'm just dispatching a Kivy event like on update and passing the texture from the camera. This is the camera widget, CAM, means this widget, sorry, this object, not widget. the core camera is like object, Python object. Okay, so it will just pass the cam object, and it will just send the cam.texture for 30 times per 1 second. Okay, so it will just you have to just you will get the every texture for every frame in on update event. Okay, so now come to our main application. So it will just application like inherited from app, and it is like fn equal to string something like parameter. Okay, this is a build function, and I'm just taking for Android, it will take permission from the user. Okay, like camera permission. Okay, and count is equal to 0 for the particular variable. So sorry, like it is equal to count equal to 0, because I am doing Dlib's image detection stuff. Okay, it will need actually. Now it is the box layout, and in box layout it is like orientation is vertical, some spacing padding, and I'm just adding the camera widget here, and I'm just initially it is play equal to false. So it should not take frames from the camera hardware. Okay, by default. And size hint, okay, because it is from it is built using relative layout. Okay, now the camera widget I'm binding on update to like update. So whenever the frame comes, on update will call the update function is here, which is written in here. Okay, so so now, and then there's some button to like play pause button, and the button will do some play pause function. When on release will event will, when you just press the button, it will call the play pause function. Means on release means when you just release the button, and when there is something like on press and on release event, and I'm using on release event here. Okay, this calling the play pause. And some title Dlib equal to Dlib text equal to Dlib Python face detection on the Kivy Android. Okay, and some something like face numbers. This label will show how many faces are detected. Like this is the change camera. Okay, so I'm just use a toggle button to change the camera facing. Means you have more than one camera, then it will change the camera. And camera this button, and I bind some event with this. Okay, and some box layout again, and I'm just doing something like something some layout stuff. Okay, and title, number of face level, and camera widget, and some box stuff. And here I'm just initializing the Dlib get frontal face detector, which is the delay object. Okay, and I'm just returning the layout, which I'm just build is here. Now the update function will call every frame. It is not in UI thread. Okay, it is in another thread. So UI thread is more powerful, and to draw everything like widgets, drawing, okay, like all Kivy stuff. But actually it is like another thread which is not very strong. Okay, so if you do something like UI stuff, then you should use the main thread. Okay, so do process all the computation here, and you should call something like a main thread to update. Okay, something like, see here I am just getting the texture which coming from the camera side. Where is that? This is the update. Okay, and I'm just passing the camera. So where is that? Yeah, here I'm just dispatching the on update event, and this is the camera texture. Okay, and it is, I'll get all the texture for every frame. Okay, so yeah, here, so I'm getting texture from every frame from the camera hardware. Okay, now I am just written here some function like texture to numpy, which will convert this Kivy texture to numpy like RGBA. Okay, to process images like gray image like RGBA. Okay, and how it will work. How it will work, I will just discuss. See, it is the I'm just calling texture to numpy, and here the texture to numpy is here. So see, this is the texture is coming, it is Kivy texture, and it is, I'm just taking the texture dot pixels, okay, and this is the size of the texture, like width and height. So now I'm just creating frame, means that it is pixel, and from numpy dot np dot from buffer, okay, it is like a byte string, something like byte string, okay, and I'm just converting to like a frame, okay, with some okay, and like a array or some whole array with something like numbers, but this texture dot pixel or pixel is like a byte string, okay. So now I have to just reshape to get the RGBA, like width, height and width comma 4, okay. So this is that this is the numpy reshaping, okay, and now Dlib is support RGB, okay. So what we have to do, we have to just take take up to the 3 okay, and we have to just remove the last one, okay, like A, means that A means the transparency, okay. So this is the numpy array like numpy operation or slicing, numpy array slicing to get the RGB, okay. This is something like matrix, okay, which is like the dimension is like height into weight. So whole dimension is width cross height cross 4. Now the dimension, sorry, it is like 3, and but previously it was like this dimension, okay. Okay, so it is like now it is RGB. So using OpenCV you can do it single click, but you can also do in numpy way, okay, because numpy is very optimized and powerful module to manipulate arrays, okay, and it is very fast. Now when it is like desktop or operating system like Linux, I am using Ubuntu, so you don't need to do all this type of operations, but in Android you should rotate those array, okay, like if it is index is 0, that is means back camera, then you have to rotate 90 degree, okay, and you have to just k equal to 3 means that flip the upside down, okay, like this. Do the RGB, do it for RGB, okay, and also you have to flip left to right, and also for the frame means that RGBA, this is the frame, and it will just do for frame same thing, and else if it is the front camera means that you don't need to just don't need to do like say like flip left to right, you just do only the rotation, okay, and you don't need to like upside down, okay, then k equal to 1, okay. So and then you just add this line to make actually RGB to gray. It is like standard way to just convert every okay, means that every you can also do some mean actually and do some average stuff, but it is the standard way to do that, okay. So means for R red I'm just multiplying this 0.299 for red matrix, and I'm just multiplying 0.55587 with the green matrix, and this is the also for the blue matrix. I'm just making those things, okay, and just adding again, Okay, this is the like a matrix operation, okay, to do that. now it will return the gray and frame. See, dlib will run fast at when it is using gray. Gray means black and white, okay. So also it will work for RGB, but it will run slow, and it is like RGB. The frame is that RGBA. Okay, this is the RGBA. Okay, now it is come to here again. Okay, and I'm just copying the gray, and this is the it is detecting the faces like detector, which is the dlib object. Okay, dlib get frontal face detector object, and I'm just passing gray and comma 0. Okay, so and here I'm just setting to f underscore n equal to some detect how many faces is detected, and I'm just taken a empty list like codes, and for every face I'm just picking coordinates. Okay, and this is the coordinate, and I'm just appending that code to codes. Okay, and it is length is number of faces 0, then codes is equal to empty. And now I'm just calling like texture update. This is the RGBA. Okay, I'm just passing the RGBA. What is the RGBA? RGBA means that frame which is come from the here. This is the frame. Okay, you have to update two things. One, I'm just telling you one by one. So okay, just this is the texture update, and I'm passing the RGBA, and this is the texture update too, like gray. I'm just passing gray and codes. Okay, for texture update, it is used to just paste the texture on the camera widget is here. Okay, see, previously what I have done here, I have used the rect, and here I will put the texture. How? I will just show you. Okay, wait, and I'm just creating, this is the frame, RGBA frame, and this is the height and width. Okay, and I'm just creating the texture width comma height. See, it is the numpy array. Okay, don't mess with that. And this is the Kivy texture, and I'm just creating the texture in RGBA format, and I'm just doing bleed buffer, and this is the frame RGB, and I'm just converting to bytes. Okay, and this is like RGB and form byte form. Okay, and I'm just doing the flip, vertical flip is here, and then I'm just pasting the texture, this text which I've created, where the rectangle. Okay, dot texture is equal to text, means that I'm just pasting the text to this rectangle dot texture. So now it will show on the screen, and I'm for safety purpose I'm just updating the canvas. Okay, okay, then what it will do, it will just take image from user, and it will just show you like see. So I'm just showing you the camera. Okay, and see, it will just it will take texture, and it is something like so. So camera hardware will take the wait, so this core camera will get texture from the hardware of the camera sensor, and it will just send to using the update texture. Okay, and it will come to, so what it will just some Kivy texture. Okay, then we have to just convert it into a pixels, mean that byte string, and then I'm just converting to a numpy array. You can do further process here also. What you can do, we have done something like I'm just, this is the RGBA, the NumPy array, and I'm just converting, creating some texture. So and just converting the NumPy to bytes. Okay, then doing some flip vertical, and then I'm just pasting the texture is equal to the camera widget rect dot texture. Okay, and I ask update. Now, so now our face or our the image from the camera, it is like appeared on our screen or Kivy widget. Okay, so now we just have to do one thing. As this Dlib detecting faces and it is stored in codes, then what I am going to do here, I am just sending that gray and codes to a something like drawing rectangle around the face. Okay, to do those stuff, then I'm just calling this texture update to see. While you are doing like texture update or like something like widget stuff or Kivy stuff, then you have to use the main thread, means the UI thread. Okay, so see, I'm just calling the main thread from the clock, Kivy clock. Okay, otherwise it will not work and may crash. And this is the texture update 2, this is gray and this is code. If there is something codes, okay, then it will clear the canvas. I mean, I have to clear the canvas. Okay, and for the code, and from the codes it will just unwrap the value like x, y, width and height. Okay, then I have to do some conversion stuff. So this is the gray and this is the shape, means the NumPy array height and NumPy array width. Okay, means how many how many elements are there, and this is the widget width and this is the widget height from the Kivy camera, and some doing some scale factor. Okay, something like widget height width comma image width or something like that. Okay. So now this is like x, which is detected by the Dlib, and I'm doing some scaling, multiplying with some scaling with scale x, and also for height, also for width, but not for same thing, not for y, because Kivy coordinate and some NumPy coordinate are different, or OpenCV coordinate. Okay, like it will just upside flipped y. Okay, means if it is your, so just for say, if this is the 0 0 of the Kivy, and this is the 0 0 of the OpenCV or NumPy or something like that. Okay, so we have to do flip the y, otherwise it will not work properly. So then what I have to do, I have to do this conversion equation, like this is the image height, something like y plus height, and something like multiply with scale y. This coordinate transformation needed to get proper alignment. Okay, and now I'm just attaching the drawing on the Kivy camera on where just self.camera widget.canvas. Okay, okay, and this is the color. I'm just choosing something like blue like color, transparent blue, and this is the rectangle. This is the rectangle x and rectangle y, and something like size what we have just calculated, and here something green, and this is the line by using some line rectangle. Okay, and now so something like rectangle and some square is shown on the screen, and okay, so this is the like some camera. Okay, so if it is not actually there, then you should clear the canvas. Okay, otherwise it will just draw this type of thing. Okay. Okay, now just set the set the set the num face, set the num face text equal to self.fn. Okay, means that the number, how many face number is here. Okay, so So that's it. And now I can also do what, I can also change the camera index. So this is the camera index, something like that. Okay, so see, if the state is normal, then to just switch off the turn off the camera, then is equal to 0, and then set the index of the camera widget equal to camera index. Okay, means it is 0. And also some change something like on the button text, and also if it is actually playing, then it will play again. Also it is for same thing for also the index 1. Okay, and this function will just play pause, something like if it is like false, then it will throw or toggle the camera, and something like if it is actually stop, then you should clear all those stop. Okay, so this is how it is working. And now I'm just running those to show you how it is. So this is the thing actually. Now I'm just playing the camera. I'm just covering with my finger. Okay, you will not see the actually but it is working, but it has only one camera. My laptop has one camera. So now we will test on this, will test on Android. Okay, so it is working on actually it is working on desktop as very well. Okay, now to convert into Android, see, Dlib is working on desktop very well. Okay, but to run Dlib on Android, you need some recipe or build process to just build for Android. Okay, do some compilation, all those stuff, because Dlib is C++ library. Okay, and something like Python wrapper is there with PyBind. So now I just written some recipe. This is my Dlib recipe, and this is the Dlib recipe, something like here I will push in GitHub. So this will automatically build Dlib for you. You don't need to bother about all those build process, it will automatically build. Okay, then what you have to do, you have to use this buildozer.spec file. Okay, and something like a name or package name, some like some requirements like Python 3, Kivy, set tools, CMake, Dlib. Okay, you have to just mention Dlib is here, and Android Pythonus. Okay, and what you have to do, as you are just using local recipe, you have to change something like yeah, see, you have to just add this line because you are just building local recipe. So this is the Dlib recipe, and which contain the Dlib recipe. Okay, this is the local recipe folder, and this is the Dlib recipe, which is contains the init.py. So now you are here, and also you should use the Python master version, P4A master version. By default it is master, so I'm not using that. And also you should just add camera permission, otherwise it will not work. Okay, yeah, see the camera permission. You don't need write external storage and read external storage. Okay, you don't need that. You need internet and also camera. Also okay, internet is by default is here. Okay, so now let's try to test the Dlib application with Kivy. So see, note one thing, this image processing or image converting like Kivy image to NumPy. Okay, so it is not limited for Dlib. You can extend for other cases. Okay, so you don't need to add more modules like OpenCV. Okay, all those stuff. This is enough. Python NumPy is enough to do all those stuff. Okay, just see how you can use Python NumPy, and easily you can do that. If it is necessary like to use OpenCV, then you should use that. but in my case, if I use like OpenCV, it will be very easy to do all those conversion stuff. Okay, as I'm not adding OpenCV because it will increase my application size. Okay, so NumPy is enough, and NumPy is so fast. Okay, that just convert pixels, means the texture to pixel, it is the byte string. Then it will just use this NumPy np.buffer like pixel, and then reshape that. You will get RGBA if that texture is from RGBA. Okay, and then you should convert like RGB, like using something like Python NumPy slicing, and also do some rotation or other stuff. Okay, so this is all NumPy, and all those things are running in CPU, doing in all those things in CPU, not in GPU. Okay, but Python NumPy is so optimized and fast, you don't need to think about that. Now let's time to test the Dlib face recognition application in my Android phone. Okay, so you will get the, okay, so let me try this. So this is the application running in my phone, and I'm just doing something like to, so this is the phone, and I'm just running the starting my camera. So it is the back camera, and I'm converting the front camera. So see how it is working. Actually it is working very well, and I'm just, yeah, so this is how it is working, and on Android. And see, this is, I'm using the for loop. This mean something like, if you have something like 10 faces, then it will just draw 10 rectangle stuff. Okay, so this is how it is working, and which is very beautiful and nice. So, and Dlib is working on Android. So that's it. I will put the GitHub link for this build, and for my some repo. Okay, and you just you can use play with Kivy, and okay, implement your own and make your complex application like face landmark, or like okay, like attendance like app. Okay, the Dlib can do the face matching. Okay, you can do that, like attendance like office or college attendance like application using Dlib, and Kivy also. So that is how it is working, and just use this and enjoy, and like, share, subscribe, share my video, so everyone will learn how Kivy is powerful and how you can build and with Kivy. Okay, so that's it for today. So thank you.